In this part, we learn about the orthogonal projection of a vector onto another vector. So here we have two vectors u and v, and the projection of vector u onto vector v is denoted by projection of u onto v. We can think of the shadow of vector u on the line through vector v. So this vector is a projection of u onto v. So in the case the angle is less than 90 degrees, the projection has this direction, the projection of u onto v. In the case the angle is obtuse, so it's bigger than 90 degrees, less than 180, then the projection of u onto v go like this. However, in both cases, we do have the same formula. The projection of vector u onto vector v can be computed by this formula. Now, let's try to understand why we have this formula. The case where the angle theta is less than 90 degrees. Let me do this first. The second case would be the same. So now we have vector u, say this vector, and vector v is here. So the angle between them, theta, is less than 90 degrees. Now the projection of vector u onto vector v, if we project orthogonally, so here I project it orthogonally, this angle is a right angle. The projection of u onto v gives us this vector, to the purple one. That one, we call it the projection of vector u onto vector v. So now let's compute it. Let's look at this right triangle. So here, let me draw it again. Here's a right triangle we have. So here's the angle theta. The length, hypotenuse here, is actually the length of vector u, right? The length of this side is the length of the projection of vector u onto vector v, so this length, right? So by cosine of the angle theta is this length here divided by the length of u. Length of projection of u onto v divided by the length of u. So this gives us, or in other way, projection of u onto v is actually length of u times cosine of theta. So now we have the length of the projection vectors. That projection vectors goes the same direction as v. So what we do to form the vectors is we just multiply the unit vector of the same direction as v. The projection vector, the actual vectors, not just the length, of u onto v is a vector with this length, right? So this is the length, and times the unit vector with the direction of v, right? And that one is vector v divided by its length. This vectors here is the vectors, the unit vectors with the same direction as v, and this one is the length of the projection. So this is scalar times the unit vector. So this vector is actually the projection vectors, the projection of u onto v, and that is this formula. You can do the same with the case theta bigger than 90 degrees, and you will get the same formula. So if you need to memorize that, just remember how to compute it for the case the angle is acute, and you can use the formula for the case the angle is obtuse. It's the same formula. And this coefficient, this scalar, we call it scalar component of u in the direction of v. So the scalar components of u in the direction of v is length of u times cosine of theta. This is the length of u times cosine of theta. That is scalar projection. So we have the first part of the projection, the formula we just show here. What about the second equality? So now let's do it this way. We have here the length of u, cosine of the angle theta. Now I can do it a bit further. So this one equal to, I copy everything the same here, and I multiply the length of v divided by the length of v. So I multiply by 1, nothing changed, right? And now we have the length of u, cosine theta, the length of v. I can group them together. Length of u, cosine theta, and length of v. So let's put them together. What's left over is times vector v divided by the length of v times the length of v. Length of v square. So this one equal to the first term. Remember that u dot v is length of u times length of v times cosine of the angle between them. So the first term here give us the dot product u dot v. The second terms keep the same. The second term is this. The second terms I can also write down as vector v divided by vector v dot vector v. Vector v dot vector v is actually length of v square. So say for example, here's just explain it a bit. So vector v, say, assume that in three-dimensional space, ABC, for example, vector v is ABC, and then you do vector v dot vector v, A, B, C. So this is A square, B square, C square. So this is vector v dot vector v. But this is also the square root A square, B square, C square, own square, right? Square of this square root, so what happened inside here. But actually, this square root is the length of v. So it is the length of v. What happened inside? Square. So here we have the length of v square. It is v dot v. So that one is exactly this formula. The projection of vector u onto vector v, u dot v divided by v dot v times v. U dot v divided by v dot v times v. So that's why we have that formula. So now we understood all the formula we are given here. Now let's do an example. For the vector u and vector v given as in this example, we need to compute the projection of u onto v. So let's use this formula we have. Projection of u onto v. Projection of vector u onto vector v. U dot v minus 8, 0, 1 dot 1, 2, minus 2. So this is the first term, u dot v divided by v dot v. So 1, 2, minus 2 dot itself 1, 2, minus 2. So that I have all of the scalar outside here. And vector v. The scalar multiplies with vector v. 1, 2, minus 2. So the scalar is minus 8 plus 0, minus 2. Denominator we have 1, 4 plus 4 times this vector. So minus 10 divided by 9, 1, 2, minus 2. Minus 10 divided by 9, 20, minus 20 divided by 9, and 20 divided by 9. So that is projection, and actually this is the answer, the correct answer I have. Minus 10 divided by 9, minus 20 divided by 9, 20 divided by 9. Perfect. So that is a projection. Now about the scalar. The scalar is actually about the scalar component. We have this formula, so we can use either one of them. So the first formula is the length of u times cosine of theta, and the second formula is u dot v divided by the length of v. In our case, we have the dot products, so we would rather use the second formula, because in some case when we are given the angle, we would use the first term. But now we use the second formula to compute the scalar components of vector u onto vector v. So that is u dot v divided by the length of v. U dot v, we computed that. U dot v here, which is minus 10. Length of v, which is actually the square root of that. So it is 3. Is the length of these vectors. The length of this vector. So minus 10 divided by square root of 1, 4, 4, so square root of 9. So minus 10 divided by 3. So that gives us a scalar component of vector u in the direction of vector v. So here I have the correct answer, so it's the same as this one.